Hello there and welcome back. In this video we're going to be solving this particular problem. It involves adding vectors. So prove that the line joining the midpoints of two sides of a triangle is parallel to the third line and of the length equal to 1/2 of the length of the third side of the triangle. So to solve this we need to break up the question a bit. So prove that the line joining the midpoints of two sides of a triangle. So we're dealing with a triangle, that's what we know so far. And let's also just draw out the triangle. So let's draw a triangle right over here. Label it A, B, and C. Prove that the line joining the midpoints of two sides of a triangle. So let's just choose two sides of the triangle. Let's choose this side here, the AC side, and the CB side right there. Now it says the line joining the midpoints of two sides, so it's going to be roughly around here and here. And it says the line joining the midpoints, so you want something joining the midpoints. This is the line they're referring to, is parallel to the third side and has a length of blah, blah, blah. So it has to be parallel. So this line here has to be parallel to the third side. That's referring to the side down here that we haven't dealt with yet. So it has a length that's equal to 1/2 of the length of the third side of the triangle. So this line here, they want us to prove that this line here is equal to 1/2 the length of this one down here. And of course that it's parallel. So to do this, we're also going to label the ends here as something. So I'm going to label it an M. Next one's going to be an N. And just to write it out to make it a bit more simpler, we want to prove, what we're trying to prove here is that the M, the MN, is equivalent to 1/2 of the length of AB. So AB. This is the statement we're trying to get in order to actually solve this problem. But we can't just write it out initially like that. We need to use some other kind of logic, the addition logic of vectors, to get it. So what is Mn equal to using addition of vectors? Well, we're dealing with this line right here. So if we added the vector MC, or the line MC right here, with the Cn vector, this would actually equal this one. And what I mean by this is, what we're trying to do here is add MC, this line right here, adding on to the Cn line, adding on to Cn, that will equal Mn. That's a property of adding vectors. So this is the initial statement we're going to be working with. The next step is to open it up a bit more. Notice that in the final statement we're trying to get, it has like a fraction here, and we cannot have a fraction in this particular statement. That tells us we need to keep changing it around. So MC, how can we open up the MC vector or a line? That's talking about this line right here. So what we need to do here is recognize that the line MC is half of the line of A to C. And the reason it's half is because in the initial question it says the line joining the midpoints of two sides of a triangle. So midpoint equals half. That's why we know this line here is half of A to C, which means we can also just replace this with 1/2 of the line A to C. This statement right here is equivalent to the line MC. And of course you have to add on well, actually, let's go ahead and change the next one, Cn. So what's this equivalent to? Well, it's the same situation as the other one, the first term. It's also half of C to B. So we can replace it with 1/2 C to B. And all of this is still equivalent to the Mn over here. So now what can we do? Well, we can factor out the 1/2 because that's the common term, or common factor amongst these two terms here. So if we factored it out, we would get 1/2, then the line AC plus then the CB line is equal to the Mn. Okay, so now we have to simplify it a bit further. Let's look at the inside of the brackets, the line AC and the line CB. That's I'm talking about or referring to the line right here, the line AC and the line CB, this entire thing right there. So what would happen if you added those two lines, those two vectors? Well, you would get the line down here, you get the line AB, right? So if you did that, you would get 1/2 multiply, then we get the line AB inside. So the line AB. Sorry, it's getting a bit crowded down there. And that's equal to Mn. And of course, if you notice, this is the statement we're trying to get. The line Mn is equal to 1/2 of the vector AB, or the line AB. And that's exactly what we got. So we proved, or we solved the question, at least one of the questions. We actually did solve the other one as well. And the reason we proved that this line here is parallel to the line down here is because they're equal. Whenever you have two vectors that are equal to each other, it tells us it's going in the same direction. Therefore, it's parallel. Thank you for watching. If you have any questions, feel free to ask in the comment section below. And of course, I do hope you're having a fantastic day.